The product rule, level 3. In this video, we will go over problems that require us to use the graphs to find the derivative of the given function. Let's go over the first example. Let p of x equal f of x times g of x. Find p prime of 1 by using the graphs of f and g. Alright, this example is similar to the problems from the previous videos. We're given a function that is formed by the product of two distinct functions, in this case f of x and g of x. We also don't have an analytical expression for the function, but we are provided with the graphs of these two functions. For this problem, we are asked to find the derivative of p evaluated at x equals 1. Let's first find an expression for the derivative of p of x. Since p of x is formed by the product of f of x and g of x, we go ahead and apply the product rule. Applying the product rule, we obtain the following expression for the derivative. Next, we need to evaluate this expression at x equals 1. This means that we need to find the value of f of 1, f prime of 1, g of 1, and g prime of 1. Unfortunately, these values are not provided to us, like they were in the previous video. This time around, we need to figure out these values by making use of the graph of f of x and g of x. To find f of 1, we go ahead and find the y-coordinate of the red graph when x equals 1. Looking at the graph, we see that it would be equal to 6. In the same manner, the y-coordinate of the blue graph at x equals 1 would be equal to 4. This would correspond to the value of g of 1. Now to find g prime and f prime evaluated at x equals 1, we need to remember the geometric interpretation of the derivative. In this case, the derivative represents the slope of the tangent line at every given value of x of the function. This means that in order to evaluate g prime at x equals 1, we need to calculate the slope of the tangent line of g of x at x equals 1. Since the blue graph at x equals 1 is formed by a line, we can find the slope by calculating the rise over the run. In this case, it is going to be equal to -1/2. Lastly, f prime evaluated at x equals 1 is going to be equal to the slope of the tangent line of the red graph at x equals 1. This value can be calculated in the same manner as g prime of 1. In this case, it is going to be equal to 1/1, which is just equal to 1. Having found all the required values, we go ahead and simplify the expression, obtaining the final answer equal to 1. This problem is testing a couple of things. First, it is testing to see if you understand the product rule. Second, it is testing to see if you understand what g of 1 and f of 1 represent. In this case, they are just the y-coordinates on the respective graph at x equals 1. Lastly, do you know how to find g and f prime by using the geometric definition of the derivative? Remember, it is just the slope of the tangent line at any given point on the function. Alright, let's try the final example. Let p of x equal f of x times g of x. Find p prime of 4 by using the graphs of f and g. Similar to the last example, let's go ahead and find an expression for p prime of x. From the previous example, we know that it is going to be equal to the following expression after using the product rule. Next, let's go ahead and find p prime evaluated at x equals 4. We first need to find what f of 4 is equal to. Looking at the red graph, we see that the y-coordinate of this curve at x equals 4 is equal to 1. Likewise, g of 4 can be found by using the blue graph. In this case, it will be equal to 8. Next, let's go ahead and find g prime and f prime evaluated at x equals 4. Once again, in order to find the value of these expressions, we need to calculate the slope of the tangent line at x equals 4 for each graph. G prime of 4 is going to be equal to 0, since the slope of the tangent line at this point is a horizontal line with no slope, or in this case, zero slope. Lastly, f prime of 4 is going to be equal to positive 1/2. Substituting these values into the derivative and simplifying the expression, we obtain the final answer equal to 4. Keep in mind that whenever you need to find the derivative of a function formed by products of functions, you need to make use of the product rule. In our next video, we will learn how to deal with functions formed by a quotient of two distinct functions.